All right, in this video we're looking at how to use the graphing calculator to perform a proportion z-test. So let's look at it. It says a senatorial candidate claims that most of the people in the country feel they are worse off today than they were 2 years ago. A poll of 500 people in the country reveals that 255 feel they are worse off today than 2 years ago. At the 10% significance level, test the senatorial candidate's claim. Okay, so what we're going to do is we're going to start out with the initial steps of the process that we can't get the calculator to do for us, and that's mainly to express the claim HOHA and then list the data. So let's begin with that, right? So let's express the claim symbolically. All right, so this time the claim is basically from the senator. The senator claimed that most of the people in the country feel that they are worse off today than they were 2 years ago, right? So what we're going to say then is the proportion is greater than 50%. Greater than 50%. The proportion is greater than 0.50. Now, why do I say that? Because it said most of the people in the country feel they are worse off today. So most means more than 50, so it's appropriate to say greater than 50. All right, and then from there we're going to have HO and HA in the problem. So the claim here has the greater than symbol, so that's going to be our HA, so 0.50. And HO, of course, will express the opposite idea. So if most of the people don't think we're worse off, then it must be some number that's less than or equal to 50. Okay. And then from there, we're going to take that information and collect the data for the problem. And together with that information, we'll be able to enter that into our calculator. So in the problem, it said they conducted a poll of 500 people in the country. So that means N was 500. And then they went on to say that 255 of them felt they were worse off today than 2 years ago. So that would be the number of people, X, out of the 500 who felt they were worse off. So X is 255 in this case. And then finally, we're given a significance level. They said that alpha was 0.10. So that's our data for the problem. Turns out that's all we need for our calculator. So let's go ahead and use our calculator now to get the rest. And the rest of what it's going to give us is essentially the test statistic and the p-value. Okay, so press stat in your calculator, arrow over to where it says test, and then scroll down. You're looking for the one proportion z-test. In my calculator, that's option 5. So I'm going to highlight 5, hit enter. And when I first come in here, it asks me for p0, which is basically the number that you see in HO. So we want to put the 0.50 then, 0.50. And then for the x, we want to give it the x value we have in our data, which is 255. And then lastly, our n, which is 500. All right, now it wants us to put in the symbol you see for HA. So I see greater than for my HA. So I'm going to come over here, highlight greater than, hit enter. And lastly, press calculate. All right, so it gives us our test stat. Our test stat is Z. And it says that that answer is 0.45 if you use just 2 decimal places, 0.45. Okay, so that's our test stat. And then from there, it also gives us the p-value. So be careful, there's 2 p's here. There's the p-value and then there's a p-hat. The p-hat is simply the ratio of x and n, so that's not what we want. P-hat is just summary information. We don't need that. We actually just need the p-value. And the p-value here is 0.327. So the p-value is 0.327. Okay, so let's finish the problem then. We've got all we can get from the calculator. And so since our p-value here is larger than alpha, so 0.327, since that is greater than alpha, which is only 10%, 0.10, we do not reject, right? So large p's do not get rejected, so do not reject HO, and therefore do not support HA. Okay, so those are our conclusions, and in terms of our claim, since our claim is HA, we would be saying that we do not support the claim. So we do not support the claim. So the senator's claim doesn't seem to be valid according to this sample data, or at least the sample data is not strong enough to support the claim. Notice we can't overturn the HO, which is assumed to be true.